This is a set of multiple choice questions. They're all past paper questions from AQA Chemistry and they are all on the topic of amount of substance. So I'm going to recommend you pause on each question, have a go at answering it for yourself before you review. With that in mind, here's the first question. So we have got a reacting masses question. So let's start by drawing out the table. We're interested in the species we know about and the species we want to know about. So that's the calcium carbonate and the silicon dioxide. We're told that we're starting with 1,000 kilograms of silicon dioxide. Technically, you should be converting that into grams and then converting back to kilograms later. You can actually get away with it on this question. So if I then work through and say that the MR of SiO2 is 60.1, I can work out the number of moles as 16.64. My mole ratios in the equation show me that 1 mole of calcium carbonate reacts with 1 mole of silicon dioxide, which means 16.64 moles of calcium carbonate. My MR of calcium carbonate, calculated from periodic table, is 100.1. Multiply N and MR together, and we get 1665. Convert that back into tons. Closest we're going to get there is 1.67 with the rounding, so the correct answer is C. Next question. And essentially a titration calculation, we've got to be aware that ethane dioic acid has 2 COOH groups, which comes up more in year 13. But if we take a look, this is the equation that we're dealing with. My ethane dioic acid reacting with KOH to make our salt and our water. But I need to balance it. I need 2 KOHs and 2 H2Os. That's important because now we can start to fill in our table. So our table is the ethane dioic acid and the potassium hydroxide. I have been given concentration and volume of KOH, remembering to convert volume into decimeters cubed. I can work out my moles, and then I can use the 2-to-1 mole ratio that I've just established to say that I've got 1.125 by 10 to the minus 3 moles of ethane dioic acid. I've also been given a volume for that, 25, converted into decimeter cubed, divide by 1,000. And finally, I can do my calculation to find C, which comes as 0.045. Correct answer is B. On to the next question. And on here, we have got the equation to begin with. Silver oxide reacting with hydrogen. We know that if it's reducing the silver oxide, it's taking the oxygen. So we're going to make water. I then need to balance that equation. So 2Ag. From there, I can fill in my table. I've been given a mass of silver oxide. I can find its MR, 231.8. From there, I can calculate my number of moles. And then I've got my mole ratio from the equation, 1 to 2. I've got 0.02 moles. Then I have my MR of silver, which is 107.9. I do my final calculation, N times MR, and I get a mass of 2.16 grams. Correct answer is D. And then let's move on to the final question in this set. Again, I'm going to draw out my table. I have got 0.85 tons of iron oxide, and I'm just going to transfer that in as grams, and we just scale up. It's 0.85 because we have 1 ton of the ore, but only 85% of it is iron oxide. From there, I find the MR, 159.6, which allows me to calculate N, 0.005. My mole ratio is 1 to 2. I'll get 2 ions from every iron oxide. And then 55.8 as my atomic mass for iron, multiply those together, and I get 0.594 rounded to 0.59 tons. Correct answer is A. That takes us to the end of this set of questions. Thank you for listening and goodbye.